So doing this CET question expert 4/7/2024 July's paper. So I will be dealing with wave optics part. So we'll go to first question. In the Young's double slit experiment, the two slit act as coherent sources if equal amplitude A and wavelength lambda. Okay. Okay. If they have equal amplitude and wavelength lambda. In another experiment with the same setup, the two slits are sources of equal amplitude A and lambda but are incoherent. Okay. So in one case, coherent source is used, and in another case, uh, no difference, only difference is incoherent sources. Everything else is same setup. The ratio of intensity of light at the midpoint of the screen in the first case to that in the second case is. So midpoint means central point, है ना? Screen's midpoint is central point. So here they are asking interference, and here we know it is constructive interference. So in the first case they are coherent sources. So intensity will be 4 I naught. Right? And here they are incoherent sources. So here the intensity will be it will be average intensity which is 2 I naught. Correct? Because they are incoherent, all phase differences are possible for any small given interval of time. So we average the intensity for all phase differences. So we get 2 I naught. So now first case by second case is 2:1. That is first option. So then go to second question. Two waves of same frequency and same amplitude from two monochromatic source are allowed to superpose at a certain point. If in one case, okay, if in one case the phase difference is 0 degree, then another case, in other case pi by 2, the ratio of the intensities in the two cases will be the same amplitude, same frequency. Same frequency means coherent sources. So now same amplitude means both have same intensity initially, I naught, suppose. So if phase difference is 0 degree, then uh, uh, it is a constructive interference, which which we get 4 I naught. Basically, I is equal to 4 I naught cos square phi by 2, where phi is the phase difference. This is the formula. When phi is equal to 0, then cos 0 is 1. We get 4 I naught in first case. And in second case, what we get is pi by 2. Pi by 2 by 2 is pi by 4. Cos pi by 4 is 1 by root 2. 1 by root 2 whole square is 1 by 2. 1 by 2 and 4, 2 times cancel. So we get again 2 I naught. So this by this is 2:1 again. So it is option B. Then we go for the next question. A beam of light of wavelength 600 nanometer from a distant source falls on a single sorry falls on a single slit 1 mm wide. Okay, this single slit and the resulting diffraction pattern. So it is diffraction. So in this diffraction, this is wavelength of the light used. This is A slit width, and resulting diffraction is observed on the screen 2 meter away. So this is your D, capital D, distance of the screen from the slit. The distance between the first diode fringes on either side of the central bright fringe is okay. So suppose this is a this is the diffraction experiment. This is your slit here. So we know that the first minimum or the first dark fringe comes at uh, theta is equal to lambda is equal to theta is equal to lambda by a is equal to x by d. Yeah, so this distance is lambda d by a, first dark fringe. You can see the notes, it's called there. And so symmetrically, this will also be at lambda d by a distance. So lambda d by a into lambda d by a plus lambda d by a will be the distance between the two dark fringes, first dark fringes on either side of the central fringe. So our answer is 2 lambda d by a. You can solve it. 2 lambda is given 600 nanometer D is given 2 meter, A is given 1 mm. Okay. If you solve, how much you will get? 6, 10 power minus 7, and D is, capital D is 2, A is 1 mm, which is 10 power minus 3. 6 to the 12, 12 to the 24, 24 into 10 power minus 4, 24 into 10 power minus 4 meter. So it will be 2.4 mm. Option D. Okay. Go to the next question. In an inference pattern by two identical slits, okay, the intensity of central maxima is I. Okay, so 4 I naught is I. If I naught is the initial uh, intensity of each slit's light, what will be the intensity of the same spot if one of the slits is closed? Okay, so if one of the slits is closed, only I naught will come now. So I naught will come, and it will be I naught falling there at the center. So initially it was 4 I naught. I naught was coming from one of the slit, and I naught was coming from this slit also. I naught was getting combined to become 4 I naught. It's construct interference. But now slit is closed, so only I naught will come, and it will be I naught. So, so, so okay. And I naught is equal to I by 4. So is I by 4. In Young's double slit experiment, we get 60 fringes in the field of view of monochromatic light of wavelength 4000 angstrom. Okay. If we use monochromatic light of wavelength 6000 angstrom, then the number of fringes obtained in the same field of view is view R. Means they are basically telling screen's width. Same field of view means till there we can see in the screen. Means the screen is this much only, suppose, like that. If screen is this much only, then screen is this much only. Initially, you'll get some fringes depending on fringe width. And if you use different wavelength, if you increase wavelength, fringe width will also will increase. So less fringes will come on the same width or same area of the screen, on the same screen, है ना? Same size screen. So earlier 60 were coming. So earlier 60 beta were coming. Now they are asking 60. Okay, 60 fringes we are getting. So 60 into one fringe width. So that much is the length of the screen. So this should also be equal to later thing. Later, suppose n fringes are there, which is required, n into beta dash. Right? Beta dash is fringe width when this lambda is used. So again, beta is equal to lambda d by d. So uh, only lambda is changing actually. D and d are same only. N into I can cancel it actually. Lambda dash suppose d by d cancel. So n is equal to 60 into initially lambda was 4000 and now lambda is 6000 angstrom. So I can write it as 4 by 6, correct? So it will be 2 by 3. 1 is 20 is 20 into 2 is 40. So n is 40, which is option C. Okay, so now we'll go ahead to the next question. The next question is sixth question. So what is the sixth question? Two slits separated by distance of 1 mm. Yeah, this is D are illuminated with red light of wavelength this much lambda. The interference fringes are observed on a screen placed 1 meter from the slits. So this is capital D, slits distance from screen. Then distance between the third dark fringe and fifth bright fringe is equal to. Okay. So where you will get your third dark fringe? Distance between third dark fringe and fifth bright fringe. Okay. So if you see this, suppose this is your screen. So here you will get your 0th bright fringe, then first dark, then first bright, like that second dark, then second bright. Like that, I are asking third dark and fifth bright. So position of first dark is at we'll get path reference will get as mm, xd by d. Path reference is xd by d. If path reference is n lambda, then you will get your bright fringe. This will be your nth bright fringe. Fifth bright fringe is 5 lambda d by d. This is the position of fifth bright fringe. And third dark, and you will get dark here when it is 2n minus 1 or n minus half lambda. N is equal to 0. Okay. N is equal to 1. Yeah. Starts from n is equal to 1. If n is equal to 1, it is first dark. So we want third dark, which is 3 minus 1 by 2 into lambda d by d. That will be x. Correct. This is path reference. Path reference is this much. So when path reference is n lambda, it is bright fringe. So n is equal to 0. If you put 0 bright fringe, you will get n equal to 1. First bright fringe you will get n equal to 5. Fifth bright fringe position you will get. That is this. Then if then I took for dark fringe. So for dark fringe n minus half into lambda, I took path reference should not be n lambda. N lambda and 1 lambda by 2 extra or less. So n minus 1 by 2 into lambda I took. N is equal to 0. If you put minus lambda by 2 will get. That is not into our consideration. Minus lambda by 2. If you put n equal to 1, 1 minus 1 by 2 is 1 by 2 lambda by 2. Okay, lambda by 2 is first dark. So n equal to 1 first dark you are getting. N equal to 3 third dark you will get. So position of this third dark will be 3 minus 1 by 2 is 6 minus 1 5 5 lambda divided 2d. So now you subtract both of them, you will get the distance between them. So it will be 5 lambda d by d minus lambda d by 2d. So it will be 5 by 2 lambda d by d only. Right. So now you try to solve it. Now only substitution is remaining. Okay. So 5 lambda d by 2d. Substitute it. 5. What will get? 5. Lambda is how much? 6.5. 0.5 into 10 power minus 7 lambda d capital D is 1 by 2 small d is 10 power minus 3. So this will 10 power minus 4. Then 6.5 f into 5 is 5 5 is a 25. 32 by 2 into 10 power minus 4. All are in mm. So this is in meter. 10 power minus 3 if you take off, it will be 3.25. 3.25 by 2. 1 the 1 the 1 the no 6 the then 2 the 5. 1.625, that is 1.63. Okay, we'll go to 7th. How will the diffraction pattern of single slit change when yellow light yellow light is replaced by blue light? The fringe will be okay, wider, narrower, brighter center. Okay, brighter center will not come because intensity of light is up to us how much we put, how much bright we put. Uh, so fringe width, if you see, it is lambda d by d. So now yellow light and blue light with Goer, if you see, Vibgor, lambda of red is more. So lambda more implies more wider, है ना? More wider will be the fringe. The fringe width increases. So it is yellow was there. Now it is replaced by blue. Yellow light is replaced by blue light. So it was yellow, it became blue. So lambda decreased, so it becomes narrower. Yeah. Yeah. We'll go for uh, 8th question. I will solve later. So for now, we will skip it. We go for the 9th question. What is the 9th question? In Young's two-slit experiment, the distance between the two coherent sources is 2 mm. Okay, so this is also simple only. This is D. The screen is at a distance of 1 meter. This is capital D. If the fringe width is found to be 0.03 centimeter, it is beta. The wavelength of the light is. So this is simple. Beta is equal to lambda D by D. So lambda is given. No, lambda has to be found. D is given. D small d is also given. Beta is also given. So just find out. Then nth bright fringe. If red light okay, lambda 1 is equal to 7500 angstrom coincides with n plus 1 bright fringe of green light. The value of n is okay. So nth bright fringe है ना. So on the screen, if you see, this is the screen, suppose. Okay, double slit experiment. Okay. So here nth bright fringe. So this is 0th bright fringe, then first dark, then first bright. So like this we have. So first dark means 1 beta, 2 beta. Second bright means second dark will be there, then second bright. The second bright means 1 beta, 2 beta, 3 beta, 4 beta. So means 2 betas will come. So nth bright fringe means how much will be its length from the center. Nth means 2n beta, correct? So this length should be equal because they coincide. They are at the same position. So the length should be same. X should be same. So n plus 1th bright fringe of green light means same thing again. 2 n plus 1 into beta. So now beta, okay, beta dash. So now 2n, 2 cancel. I will cancel 2. So now n lambda d by d, and here also lambda d by d. But lambda is different. D and D are same. So d I will cancel. So only lambda I will keep. So this will be lambda 1, and this will be n plus 1 into lambda 2. So now we can solve. N we have to find. Lambda 1 is 7500, correct? Into n plus 1 into lambda 2 is 6000. So 0 cancel. 15 4 the 15 5 the. This becomes 5n is equal to 4n plus 4. N is equal to 4. Correct? Now we'll go for the next question. In Young's double slit experiment, if monochromatic light is replaced by white light, okay, only one color light was there, it is replaced by white light, what will happen? So all fringes become white? No, because all don't coincide at one point. For different lambda, we have different positions. X is equal to n lambda d by d. So if lambda changes, their position changes. So they will not mix together. All bright fringes have colors between violet and red. Yeah, this can be correct because Yeah, all bright fringes will have. So here red will come, then blue, like that. Vibgor will come because it depends on lambda. So if lambda is less, its position will be less. Like that, all other will come. Only the central fringe is white. All other fringes are colored. Okay, this is also correct. Okay. So C is also correct. All other fringes are colored. That is this. Okay, this is all bright fringes. Central bright fringe will not be colored because all wavelengths will mix there, है ना? All will mix there. All other x will be different because they depend on lambda. But central bright fringe x n is equal to 0. So whatever lambda it is, they all will form central fringe there only. So central fringe they mix. When they mix, Vibgor mixes, it becomes white light, and so all the fringes are colored. So option C is correct. Okay. No fringes are observed. This is wrong. Option C. Correct. So we'll go for the next question. 11 is over. 12. Um, a beam of electron is used in an Young's double slit experiment. The slit width is d. Okay. Uh, okay. Slit width is d. Okay. When the velocity of electron is increased, then what happens? Okay. The interference of the fringe width increases, fringe width decreases, fringe width remains. Okay. So fringe width is lambda d by d, right? So if velocity of the electron increases, this will also not increase. This will also. Well, there will be no change between in capital D and small d. It is experimental setup. So only thing remains is lambda. And for a electron, we know lambda is equal to h by p, correct? Or lambda is equal to h by mv. So if velocity of the electron increases, h and m are constant. If velocity increases, lambda decreases. If lambda decreases, beta decreases. So if velocity increases, beta decreases. So fringe width decreases. It is 12C. Yeah. Then we have 13th. In Young's double slit experiment, the intensity on the screen at a point where path reference lambda is k. Okay. If path reference is lambda, it is constructive interference. So k will be 4 I naught, correct? What is the intensity at the point where path reference is lambda by 4? So here path difference is lambda by 4. So phase difference is 2 pi means 2 pi by 4, that is pi by 2. Means lambda indicates 2 pi phase difference. So lambda by 4 indicates pi by 2 phase difference. So if it is pi by 2 phase difference, what will be the intensity? Hmm. Hmm. 2 I naught square. So it will be, no, it is 4 I naught cos square phi by 2. So if phi is pi by 2, then pi by 4 is cos pi by 4 is 1 by root 2. 1 by root 2 whole square is 1 by 2. 2 I naught. So this will be 2 I naught. So and 2 I naught. 4 I naught is k. So k by 2 will be 2 I naught. That means is B. B. As we know in in interference, I means resultant intensity is 4 I naught cos square 5 by 2, where I naught is the intensity of individual waves which are interfering, and phi is phase difference between them. So if phase difference is 0, path difference is lambda, phase difference is 2 pi. 2 pi by 2 is pi. Cos pi is minus 1 whole square is 1. So it becomes 4 I naught. It's constructive interference case. And if it is lambda by 4, then phi is put 2 pi in place of lambda, it will become pi by 2. So pi by 2 is 5. Pi by 2 by 2 is pi by 4. Cos pi by 4 is 1 by root 2, 1 by 2. That is whole square 1 by 2. 4 I naught into 1 by 2, 2 I naught. 2 I naught is k by 2. Right? This k is 4 I naught. We'll go for 14th one now. This is a good question. What is the question? A beam with wavelength lambda falls on a stack of partially reflecting planes with separation d. Okay, here it is their diagram. So its wavelength is lambda. This separation is d. The angle theta that the beam should make with the planes, so that, okay, this is theta, so that the beams reflected from successive planes, means this plane and this plane, successive planes, may interfere constructively is okay. They want constructive interference, and n is an integer, means natural number. So how to find? They are telling these two should interfere constructively. So the path reference should be n times of lambda. Then only we will get constructive interference, correct? Where n goes from 1, 2, 3. It goes from 0 only. But in this case, we will have it is 1 because 0 is not possible. Okay. Anyway, that is not so important. So now delta x is path difference. So path difference is how much here? If you see, if they are coming from some source, suppose, so they both will travel same path from here to here to here, and same path. And from here to here also. Okay, sorry. From here they both will come. So till here they will travel same distance, and here this will be same distance, and this will be same distance. So the only path reference remains is this down ray, it goes this much extra path. So this is the path reference. So that path reference should be n lambda. And how much is this? So this is d, right? This is theta, then this is theta, then this will be 90 minus theta, then this will be theta. So this will be theta. You see? Sorry. Like this. Like this. Right. Plane is like this, one plane is like this. This is theta. These two are your plates. These two are the rays. This theta. So I'm telling this is the one path difference, one part of the path difference, and this is one path difference. So if you this plus this will give you path difference. So how much will be this? This is theta. This will be 90 minus theta. Then this will be theta. This is a d. So this is d. Okay, this is perpendicular. Yeah, this is perpendicular. This is d. This will be d cos theta. This will be d sin theta. So d sin theta plus d sin theta will be your delta x, right? So delta x will be d sin theta plus d sin theta. This will be d sin theta plus d sin theta. That is 2d sin theta is equal to n lambda. So theta will be equal to sin inverse of n lambda d by 2d. Correct? N lambda d by 2d. N lambda by 2d. Sorry. Sin inverse of n lambda d by 2d. N lambda by 2d. Sorry. So 14th is C. Yeah, we'll go ahead. So what is the question now? 15th one. So white light may be considered to be a mixture of waves with a lambda ranging between 3900 angstrom and 7800 angstrom. An oil film of thickness 10,000 angstrom is examined normally by reflected light. Okay. Just wait. Okay. 15th I will explain you. 15th and 16th I will explain you later. Uh, Now we'll solve these 17th and 18th. After that we have electrostatics, I think. So 17th and 18th we will discuss. So three questions are remaining: 8, 15, 16. That I will explain. 17th and 18th. 17th, if you see, in a single slit diffraction experiment, first minimum for red light coincides with first maximum of some other wavelength lambda dash of lambda dash is again same. So first minimum position is in next double single slit experiment. Sorry. So first minimum is lambda d by uh, first minimum. The first minimum comes when a theta is lambda, theta is x by d. So lambda d by a. This is position of first minimum for red light. Okay, is equal to coincides with first maximum of some other wavelength. Okay. So for maximum we have a theta is equal to, for maximum it should be 3 lambda by 2. Okay. 3 lambda by 3 lambda dash d by 2a. Okay. The first maximum position is 3 lambda d by 2a. You can check it in notes if you are not getting dy cancel. So lambda dash we want, which is 2 by 3 into lambda, which is 2 by 3 into lambda is 660 nanometer. So 3 ones are 3220. It becomes 440 nanometer, which is 4400 angstrom. Yeah, it is 4400 angstrom. That is okay. It is nearly 4000 angstrom. Right. 17 is option A. Then the ninth double cell experiment arrangement shown here. If I make a sheet of thickness T and refractance mu is placed in front of S1. Okay. Here they will keep in front of S1. Then the path reference S1P. Okay, S1P minus S2P is S2P decrease by, okay, increase by, okay. So if you see this diagram, S1P is already greater than S2P, correct? So S1P minus S2P, okay, we again shift formula only. So now because we have kept it here, this thickness T and mu refractive index, its optical length becomes mu T. Here it is T in this medium, but if you replace it by vacuum, it will be mu T vacuum's length. So S1P will increase by, uh, okay, S1P was uh, this much. Now instead of S1P, we'll have S1P minus T plus mu T, correct? S1P minus T is this wavelength, this path, this much, plus this much thickness of mica sheet is there, which is equivalent to mu T of vacuum. So vacuum's length is this much now. So S1 will be replaced by this, that is S1P plus mu minus 1 into T. So S1P will increase by mu minus 1 into T. So the difference will increase by mu minus 1 into T. So it is option B. 18 is B. Okay. So the three questions are remaining. I will solve it. later. So we will end it here. Any doubts you can ask in the class.